In this collection of videos, I'd like to remind you of some topics that we've discussed regarding gerrymandering, and I'd like to set us up for the project that we'll be working on this week, which is a continuation of that. So as a reminder, in America, we live in a representative democracy where we elect people to represent districts who then go on to vote on legislation on our behalf. And what has to happen in order for that to work out is we need to take a large area and divide it into districts. And then these districts vote on a representative to represent that region. Now, there are very, very few actual laws and rules that govern what has to be true about the way that we select those districts. And as we will see, the way that we select those districts influences the outcome quite heavily. So one rule is that districts have to be as close as possible in population size. When you have population that is varying greatly because people are moving and being born and dying, it is absolutely impossible to guarantee that these districts will have exactly the same size, but at the time that the map is created, to the best of your ability, you want the populations to be close in size in the districts. And the only other rule that is very important that we abide by is districts cannot discriminate on the basis of race. That will not come up in our mathematical model, but is an important rule to know that it exists. While the first two points that we have listed on this slide are legislation about what has to be true about the districts, there are other common practices that we use when we create districts, such as we often want our districts to be compact, meaning we don't want them to be kind of snaking all over the region. We generally want contiguity of districts, meaning we want them to be what is sometimes called path connected, where you can get from one point in the district to another point in the district by just moving sort of north, south, east, west. So we don't want to be splitting districts up and having little patches all over the state that we highlight and throw into a district. Occasionally, we want to preserve natural features of the state or the region that we're representing, and we may want to preserve, to the best of our ability, the boundaries of previously drawn maps. Those are all things that occasionally get brought up with gerrymandering. None of them is a rule, but they are practices that tend to be followed in different places to different extents. Now, we're going to be working with an example that we've just called Simple Town. We're making this 100 voters. So we're going to work in a 10 by 10 grid, and we're going to imagine that we have an approximate 60-40 split of the voters in this Simple Town. What we're going to do is we're going to use the computer to randomly assign a political party to the 100 people that we're viewing as being in our Simple Town. We are going to use the computer to put people into contiguous districts of 20 people each. That's the criteria that we're going to be focusing on in our work, is the contiguity of the districts. Then our computer is going to do a little bit of a tally for us. They're going to compare. We are going to have an approximate 60-40 split, but we're going to use randomness within the computer to create that. And then what we'll have the computer do is tally up for each of the districts. Do we have Party 1 representing this or Party 2 representing this? So we'll have a tally on the number of representatives that are affiliated either red or blue, and then we'll have a different tally that talks about what is the exact split, 60-40, 58-42, whatever it happens to be, so that we can compare those ratios and get a gauge for how fair we think the representation is in our district. And then what we'll do is run this experiment many times to get a feel for what can happen in these, just according to randomness, with these different designs. So let's go over to Excel and take a look at what we did there. What we had done in Excel is we had just filled in a 10 by 10 grid where we put random numbers into our 10 by 10 grid. And we colored a cell red if it had a value that was greater than 0.6, and we colored a cell blue if it had a value less than 0.6. And that was how we came up with red voters and blue voters, just picking those things at random and getting our tally. And here we got really close, 39 red squares in total and 61 blue squares in total. We then thought of the districts in a very basic way. Just to get a feel for what was going on, we were using, let's say, these columns, the first two columns of each one, to represent the districts. That would be a real nice and easy way to do districts. And then we would count up the representatives and say, what did we get here? Well, in District 1, we had more reds than blues, so there's a red person representing that district, but then we have 4 districts here that would elect a blue representative. So when we have this 61-39 breakdown of blue voters versus red voters, we ended up with 4 blue representatives and 1 red representative. And then the nice thing about Excel is you type something into this value and hit enter, it will redo this random distribution and redo all of these formulas. And we see that we could also get a 3-2 situation going on. And we can repeat this process over and over again. Find that sometimes we don't get any red representatives at all. Sometimes we tie. All sorts of interesting things can happen here. And we could run that a handful of times to get a feel for what we expect to be happening here. However, where gerrymandering comes into things is we took a snapshot of one of these situations where we had essentially a 60-40 breakdown. We've labeled the reds and the blues in here, and then the colors in this image are showing us the districts. If we don't force our districts to just be 2 columns at a time, and we instead only focus on that contiguity, I can use the colors in the way that I've drawn here to distribute this, where we have a 60-40 roughly breakdown of the data. And if I draw the districts just so, even with a 60-40 split, I can certainly draw the districts to give the party that only has 40% of the region a majority in the district. So I could easily draw my district lines to get 3 red representatives and 2 blue representatives despite this 60-40 split. Now, if I had a little bit of a more exaggerated number, perhaps I had 44 red voters, so still roughly 40%, it seems theoretically possible that the red party could actually take 4 districts. And if you're very, very clever, you can make that happen. But every piece of our internal instinct should be screaming that that's incredibly unlikely, and that you'd actually have to be very devoted to coming up with the map just so in order to make that happen. And when we start getting that feeling for, yes, that could theoretically happen, but the only way I can see to make that happen is to really take a look at things and force it to be so, that's when we want to draw the line between randomness and gerrymandering. We're going to look at a procedure that's going to help us define that more precisely in the next video.